Now, let's try this example. Unlike the previous example, you're given a graph. And if that graph represents a function, this case, you're given a function, a general function, and you're asked to find the domain. Now read the question carefully. Like this case, I only asked to find the domain, not the range. So you read part A, find the domain of f of x, and write the answer in set notation. Part B, find the domain of f of x, and write the answer in interval notation. So only domain. So careful. Read the question. Now, for fraction, when you see a fractions and you're asked to find the domain, always ask the question, what x that when I substitute into this function would make this function undefined? If such x exists, it means the function is undefined. And we want to call out those x because those x cannot be the element in the domain. Okay, we want to find out what are the x that should not be in the domain. So ask the question, what x that when you substitute into this function, it will make this function incalculable, cannot be calculated. So given the function f of x equal to 7, 5 minus x. So for a function, we don't want anything divided by 0, right? Any number, okay? We don't want a function that has a denominator of 0. We don't want it, okay? So we want to find out what x that would make it so we can avoid those x. So when you see a function, set 5 minus x equals 0. Okay, so we want to find out what x that would make this denominator equal to 0. So that if such x exists, we don't want to use that x as domain. It should not belong to domain because it is, then the function is undefined. So let's solve for x. We use the addition principle, so we subtract 5 on both sides. Simplify, 5 subtract 5 is 0, subtract x, 0 subtract 5 is negative 5, 0 subtract x, negative x equal to negative 5. Using the multiplication principle, divide both sides by negative 1. Negative divided by negative is positive, so x divided by 1 is x. Negative 5 divided by negative 1 is 5, so x is 5. Now, if you substitute 5 here, you get what? 5 minus 5 is 0. 7 divided by 0 is under 5. So that means you should not use this point. This point should not be in the domain. Should not. So you would say part A. So if the domain is, now this asks you to write the answer in set notation. So I have set notation. What is the variable? X, right? X such that x is any real number except x equal 5. Okay, x is any real number except x equal 5. Or you can say, sometimes people would write the answer as x says that x is any real number and x not equal to 5. I accept either one of the answer. Now for multiple question, I will only use one, so make sure you recognize this set has the same meaning. X is any real number. You can pick any number for x, okay, except 5. Okay, so 5 should not be in the domain, but any other values are fine. So we say x is any real number except x equal 5. Or you can say that x is any real number and x is not equal to 5. For part B, find the domain of f of x and write the answer in interval notation. So how do we write this answer in interval notation? If you have a hard time, draw a graph, a number line graph. So 5 right here, right? We're not including this point. So how do we write this? We're not, right? Any point out is fine, so, but not this one. You can use parentheses to demonstrate that. To the left, some negative infinity, right? To the right, some positive infinity, right? Any number but 5. Smaller is fine. Any number except 5 but bigger than 5 is fine. So how would we write this in interval notation? We know that it's going to be negative infinity. Negative infinity, we use left parenthesis because we don't know what it is. Except 5, right? So we have 5 right here. Not accepting, so parenthesis, right parenthesis, union with, okay, union with is like u, not accepting 5, that's why parenthesis, okay, parenthesis, and till positive infinity. So this is the domain in interval notation. And if you have hard time, again, you can use number line. Just grab it to help you visualize how it looks like. Remember, to the left, it's like some negative infinity. To the right, is some positive infinity. So this is the answer for this example.